All right, let's talk about the natural logarithm. This is a fun lesson because by Algebra 2 you have not done this yet. We are in lesson 10.8. We're working on the natural logarithm, and we're going to get a new number today. We're learning a number. It is the number e. I know, it sounds weird, but it's just a number. If you put it in on your calculator and you push equals, e is equal to 2.71828. And if you notice, it is just log base e, and that is equal to the ln, or the natural logarithm of x. I'll probably say ln of x, which just means the natural logarithm. There are some rules that we need to use, but before we do that, let's talk about our essential question. Are you able to define and use the natural logarithm function? So it says if ln of x is equal to 5, then x is equal to e to the 5th power. So let's talk about that first. Remember that we said a natural logarithm is log base e. And I know that if I put my logarithms into exponential form, this would be e to the 5th power is equal to x. And that's what this property just told us. So we just have to look at natural logarithms as log base e, and we'll know our little rules. All right, the next rule says if e to the x is equal to 7, then x is equal to the ln of 7. And let's go ahead and talk about that. If I have e to the x is equal to 7, the one thing that we need to know that I would say star, circle, and highlight is anytime you see a ln, you need an e, and anytime you see an e, you need a ln. So in this case, I see an e. If I multiply the left side by ln, what I do to one side, I have to do to the other. And we have to go back to our properties, our laws of logarithms. And remember that this flies to the front to be x ln of e is equal to ln of 7. Well, if I look at my calculator, there is a ln button, a natural logarithm button. And if I put in ln times e is equal to 1. So, right, if ln of e is equal to 1, I know this is saying x times 1, which is just x, is equal to the ln of 7. And that is where that rule derives from. So let's go ahead and look at this. It tells us ln of e to the 5th is equal to 5. Let's look at that one first. Remember, we talked about ln and e being together, they're equal to 1. So anytime we see a ln, we need a e, and anytime we see an e, we need a ln. But remember, I could fly this guy to the front because that's what laws of logarithms tells me to do. And if ln of e is equal to 1, and I know that's equal to 1, 5 is equal to 5. Now, the next one's a little bit funkier, so we will look at that. The next one says e to the ln of 7 is equal to 7, and that's what we're working with right here. But remember, if I have e and ln together, that is equal to 1. Excuse me. But this is also saying, so if we know that we have e and ln together, and those are equal to 1, remember I could fly this guy to the front. 7 times 1 is equal to 7. So let's go ahead and look at our first example. Example A tells us to simplify. The first thing I need to do is I need to change this e to the negative, or e to the second on the denominator as e to the negative 2 in the numerator. Remember, laws of exponents tell us, or laws of logarithms tell us to bring the negative 2 to the front. And if I have negative 2 times ln of e, we know ln of e is equal to 1. Negative 2 times 1 is negative 2. It looks like I I whited out my other one. Let's look at this one. And again, this is saying log base e of 1 equals what? Which is really saying e to what power is 1? So anything to the 0 power is 1, so I would have to know that. Number 2, e to the ln of 5. You can actually just put this right in on your calculator. I know that this is equal to 1. Laws of logarithms tells me to fly that to the front. Ln and e is equal to 1. We know this is equal to 5. All right, let's go ahead and look at example 2. Remember we talked about anytime we see an e, we need a ln. Well, anytime we see a ln, we need an e. Now, I have a little trick for this, but I'm going to show you how this works first. This is saying log base e of x is equal to 2. And I know that this 2 would fly to the middle, and this is saying e to the second power is equal to x. We can keep that just like that if we want to. But I have a little trick when using the natural logarithm like this. I tell my students that anytime you see a ln, you need an e. But when you put an e in, you need to make it to the power. And the reason we do it to that power is because of this right here. So it just keeps us, it really saves us one step. But if you want to show the step, show it, because if it's better for you to understand using the one on the left, do that. But remember, e and ln together is 1, so x is equal to e to the second power. Sometimes you could leave it just like that. Sometimes they ask you to round, so just be aware of what your question's asking you. In letter B, the first step I would do is I would bring the x to the numerator. I know anytime I see a ln, I need an e, and an e to the. So you could do an e to the, I kind of say that funny. You don't have to do an e to the. You could show this as log base e of x to the negative first is equal to 2, and then bring it to the. So this is going to be the same. X to the negative first is equal to e squared. To get rid of that negative 1, I have to multiply the whole thing through by negative 1. What I do to one side, I do to the other. So x is equal to e to the negative second. And when I actually show it the way that we probably should show it, we have that as 1 over e squared, and these would be the same. All right, and here is what we're coming to. We want to be able to solve all of our natural logarithms. So if I'm solving natural logarithms, remember, anytime I see an e, I need a ln. What I do to one side, I do to the other. This flies to the front, 2x. Ln of e is equal to 1. So we have 2x is equal to the natural logarithm of 9. And naturally, solving for x, we would just divide each side by 2, where x is equal to the natural logarithm of 9 divided by 2. Now, one thing I always do with my classes is I just want you to observe, is the natural logarithm of 9 all over 2 equivalent to the natural logarithm of 9 over 2? Take a minute and push pause and tell me if those are equivalent. So I'm going to tell you they're not. The natural logarithm of 9, all of that divided by 2, I got as 1.0986, ... The natural logarithm of 9 divided by 2 is 1.5040, ... I would actually round up to a 1, but notice they are not equivalent. My answer was the natural logarithm of 9, all of that divided by 2. So make sure you answer it as you need to answer it. Just try those things on your calculator when you have questions. Great job.